Hello students, welcome back for the second part of the second lecture in the subject of Design of Concrete Structures 1. In this video, we will learn about stress strain curve for concrete and steel, which is used as the construction material for any RCC structures. So let's start with concrete. So according to IS code, the stress strain curve for characteristic strength of the cube should be like this. So after strain of 0.002, it will be parabolic and then the slope becomes 0 up to an ultimate strain of 0.0035. Now this curve showed is for the compressive strength of concrete cube of size 150 mm by 150 mm by 150 mm, and it's the characteristic curve of the cube. But as you are going to design the concrete for the full structure, then compressive strength gets reduced due to the influence of the size of the structure. When we cast 150 by 150 by 150 in the lab, it's a very constrained environment, so we can take care of each and every minute detail for the concrete. But when it comes to designing the concrete for entire structure, due to its size and due to site conditions, there can be slight variations which are seen. And hence, IS code recommend that characteristic strength for structure will be 0.67 times FCK, and the curve will be something like this. Okay, so this is called as a characteristic curve of structure. So first is for the cube wherein the stress is FCK. The next is characteristic curve for structure, that is equal to 0.67 FCK. Okay, to move on, still we will not use this value in designing, because according to limit state method, we use something called as partial safety factor for material. So this is 0.67 FCK is an actual value which is used for designing of structures. But we need to take care of the safety. So that's the reason there is something called as partial safety factor. Okay, and which is equal to 1.5 when it comes to concrete as a material. It's fixed. It's given by IS code, that is Indian standards. That is partial safety factor for concrete is equal to 1.5. So by this, considering the safety factor, we divide this 0.67 FCK by 1.5, which is equal to 0.45 FCK. So the curve will be something like this. This curve is called as the design curve. So we are going to consider 0.45 FCK as a design stress and 0.0035 as the ultimate strain. So this is the final stress strain curve for concrete. There are three curves. First is the characteristic curve of cube, and the stress is FCK. Okay, this is done in lab. Next, considering the size consideration of the structure, it's been increased to 0.67 FCK. Considering the partial safety factor, it is still increased to 0.45 FCK. So the stress that is considered for design for concrete is 0.45 FCK, and the ultimate strain is considered as 0.0035. Next, we will move on to the stress strain curve for steel. As you know, we have two types of steels that are used in designing. One is mild steel and second one is HYSD bars. Stress strain curve for mild steel specified by IS code will be like this. And we know yield strength of the steel is Fy and its characteristic strength, and this curve is called as a characteristic curve. Same as what we have seen in concrete. Steel has we can consider that the yield strength of the steel is Fy, and this curve is called as characteristic curve. Now in case of steel, there is nothing like influence of size as we assume in case of concrete. Basically steel is elastic and linear material, and design curve for steel will be like this. So this is the design curve. Now partial safety factor for steel is considered as 1.15. Again, this is according to IS standards. Partial safety factor for concrete is 1.5 and partial safety factor for steel is 1.15. So we need to consider this factor of safety for design purpose. So finally, the design stress will be Fy divided by 1.15, which is equal to 0.87 Fy. So the design stress will be equal to 0.87 Fy. As we know, yield point of the mild steel can be found from the graph. Its strain at the point we can calculate easily from Hooke's law. The strain is equal to 0.87 Fy, that is stress upon modulus of elasticity of steel, that is ES, and for all the types of steel, value of ES is equal to 2 into 10 to the power 5 MPa. Okay, so on the other hand, if you see HYSD bars, it comes out to be something like this. As you know, there is not any specified yield point for HYSD bar. Stress in HYSD bar corresponding to the proof strain of 0.002 is known as the yield stress Fy, and their design curve is almost similar to mild steel, and design stress here is also 0.87 Fy. So this is again the design curve considering the partial safety factor, which is equal to 0.87 Fy. But a strain at this point will be different from mild steel. If you look at this line, if you look at this particular line, it almost behaves like a mild steel, and hence its strain for this part will be 0.87 Fy upon ES. So due to this, it behaves like a mild steel. So from here to here, it will be 0.87 Fy upon ES. This particular triangle is same as or similar to this particular triangle, wherein this strain is equal to 0.87 Fy upon ES. We have already calculated it. So this particular triangle or this area, it will behave exactly like mild steel. So this value is equal to 0.87 Fy upon ES that we have derived from this particular equation. So now the strain at this point will be equal to, it's very easy, it's the total value here, which is equal to 0.002 plus 0.87 Fy upon ES. So it is basically addition of these two values. This is 0.002 plus this is the remaining strain, that is 0.87 Fy upon ES. So finally, in the design problem, we use 0.87 Fy as the strength of steel, and we use this strain for design even in case of mild steel. We have well defined yield point, but IS codes specify a uniform criteria for all the grade of steel, and reason here is that we want yielding of tension. The reason here is that we want yielding of tension steel at ultimate limit state, and if steel yielding takes place at ultimate limit state, then failure will be ductile in nature, and ductile failure show ample warning of impending collapse. I mean, it show some sign of failure before complete collapse. So design stress will be 0.87 Fy and its strain will be 0.02 plus 0.87 Fy upon Es for all the grades of steel. One more important thing is, if you compare the concrete curve with steel, so this is the curve for stress strain curve for curve that we have already seen, and this is the stress strain curve for first is for concrete, this is for steel. In case of concrete, we apply partial safety factor for all the stress level, that is right from this to this, and for all the from first strain 0 to the final ultimate strain, that is 0.0035. But in case of steel, we apply only for this inelastic region. Okay. So concrete modulus of elasticity is directly affected by compressive strength, that is FCK. So this is the main reason. Just listen to this. Concrete modulus of elasticity is directly affected by compressive strength, that is FCK. Concrete modulus depends on variation of compressive stresses. But in case of steel, modulus of elasticity is constant, that is Es is equal to 2 into 10 to the power 5 megapascals. We have seen in the previous slide. It does not depend on any stress level, that is why we apply partial safety factor only for nonlinear region of steel. Okay, so here I have discussed about the stress strain curve for concrete and steel, which is very important for you all to understand what working stress method is. Okay, so in the next video we will be covering the analysis of beam using working stress. This is again a prerequisite video for you all to understand working stress method. So here I expect you all to know what is stress and strain in detail. Okay. Also the characteristic strength, the design strength or the design curve, basically what it is considered, what is FCK, what is Fy, what is Es, that is the modulus of elasticity, and also understand both the curves, that is for concrete and for steel. Okay. Thank you.